Hello, this is the section 5.2 lesson on the topic of multiplying decimals. So, first of all, we're going to talk about multiplying decimals. And so there's three questions we might ask ourselves. Number one, how do we multiply decimals? Or in other words, what's the algorithm for multiplying decimals? Second question, why does this method work? And then the third question, why would we multiply decimals in the first place? So we probably all know the algorithm for how to multiply decimals that we learned back in elementary school or middle school. What we want to try to focus on in this section is to understand why this method works, and then to a lesser extent, why would we multiply decimals in the first place. So first of all, let's state the common algorithm for multiplying decimals. So there's two steps to this. First of all, we multiply as if there were no decimals. So in other words, we just ignore the decimal points and then multiply. And then the second step is to move the decimal point to the left an appropriate number of places. And so let's do a simple example to illustrate these steps and how to figure out how many places we move the decimal point. Let's take 1.36 times 2.7. So the first step is to just ignore the decimal points and multiply like normal. So we're going to take 7 times 6, which is 42, carry the 4. And then we have 7 times 3, which is 21, add 4 to get 25, carry the 2. 7 times 1 is 7, plus 2 is 9. Now we're going to add a 0, multiply 2 times 6, which is 12, so write down the 2, carry the 1. 2 times 3 is 6, add 1 is 7. And then 2 times 1 is 2. We don't add anything. And so now we add. So we get 2, 7, 16, carry the 1, and we get 3. So there's the first step in the algorithm. We ignore the decimal points and multiply as normal. Now the next step is to move the decimal point over an appropriate number of places. So what's the appropriate number? Well, we determine the appropriate number by counting the number of digits we have to the right of the decimal point in our two factors. So here we got 2 and here's 1, so we got a total of 3. So that means we're going to move our decimal point over 3 places, so 1, 2, 3, and so there's where we put our decimal point. So there's our answer, 3.672. So that's how we multiply decimals. And so now the next question is, well, why does this work? Now, I'm going to give one explanation that's a little bit different than what the book gives. And this explanation, we're going to combine 3 different ideas to explain why this algorithm works. The first idea that we're going to use here is a simple rule that we're not going to explain why this is true. We're just going to take it for granted. But this rule says that to multiply a number by the fraction 1/10, move the decimal point one place to the left. So let's give a couple of examples of what this means. Right, so here's a 15.8 times 1/10. So we're going to move the decimal point one place to the left, so this is 1.58. Next example, 27 times 1/10. Well, there's no decimal point explicitly there, but we could put it right here, right after the ones digit. And so now we're going to move that one place to the left, and we're going to get 2.7. Now in this last example, we're going to multiply by 1/10 twice. And so to do this, let's group the first two numbers together. Now we can do that by the associative property of multiplication. Remember, the associative property says that when we multiply more than 2 numbers together, we can group them however we want, and we're going to get the same answer. And so now we have 136 times 1/10. Well, that's going to be 13.6. And now we'll multiply that by 1/10. And now we can do this arithmetic, move this decimal point over one place to get 1.36. So there's the answer. So let's apply this idea along with the associative and commutative properties to further explain the common algorithm. So let's look back at this problem that we just did, 1.36 times 2.7. Now we wrote it out horizontally rather than vertically, but that just changed the way it looks. And let's rewrite both of these numbers. Specifically, we're going to write the number 1.36 as this: 136 times 1/10 times 1/10. Now we know that this really does equal 1.36 because we just did that calculation. Likewise, we're going to write 2.7 as 27 times 1/10. And we know that's equal because of the calculation we just did. Now, we're going to take this expression right here, which is all multiplication, and we're going to rearrange terms and regroup. Specifically, we're going to move the 27 over here to get 136 times 27, and then we're going to take these 1/10ths and basically move them over here so we get all of our 1/10ths together. And so we just move things around and regroup them, and that's completely allowed or justified by the associative and commutative properties. So there we've used these ideas from earlier on in the semester to rewrite this. So now let's take a step back and look at what these different terms here are telling us. So the first term, notice that we've got like our original numbers but without the decimal points. So this term says to multiply as if there were no decimals. Now the second part is we're multiplied by 1/10 3 times. Well, we just saw that whenever we multiply by 1/10, we're going to move the decimal point one place to the left. So multiplying by 1/10 3 times says to move the decimal point 3 places to the left. So this right here is what we do in step 1 of the algorithm, the common algorithm. This right here is what we do in step 2. So there we go. We took our original problem, rewrote it using that rule, and then we rearranged terms using the associative and commutative properties, and we see where step 1 of the algorithm comes from and where step 2 of the algorithm comes from. So let's just kind of summarize 2 important points that I hope you see from this explanation. Number 1, the commutative and associative properties of multiplication and this rule for multiplying by 1/10 explain why the algorithm works. So we use these ideas, we put them together to explain why this algorithm works, where those steps come from. The second point is kind of a really big point that this example illustrates, is that in mathematics we put together many simple properties or rules to explain why a complicated rule is true. So like in this example, we started off with simple properties or rules. We had this rule for multiplying by 1/10, which is simple. We had the commutative property, we had the associative property. Those were all relatively simple. And we used those to explain why this complicated rule for multiplying decimals is true. Now, next question, or the third question we asked ourselves is, why would we multiply decimals in the first place? Well, there's at least 2 reasons that we would multiply decimals. The first is to find the area of a rectangle. Remember when we talked about area, we said that an area of rectangle is width times height. Now, we justified that using whole numbers, but that idea applies to decimals and even fractions as well. So, for instance, if I've got a rectangle that's, say, I don't know, 1.2 by 3.6 inches long or high, then the area is just 1.2 times 3.6. Now, we won't do that arithmetic, but again, this illustrates why we might multiply decimals in this example to find area. The second reason we might multiply decimals is to find some total quantity. So what do I mean by that? Well, let's look at a real simple example here. Suppose that 1 gallon of gas costs $2.70. Then how much would 1.36 gallons of gas cost? So this kind of looks like a multiplication problem, and let's verify it's a multiplication problem by asking the same 4 questions that we always ask ourselves when we set up a multiplication problem. So question A, what is an item? Well, we look at the question. The question is, how much does a gallon of gas cost? That's really asking for what's the total number of dollars. So an item is $1. Now what's a group? Well, a group is like a gallon of gasoline, so a gallon. How many gallons do we have? Well, we're told we have 1.36 gallons. And then how many items are in a group? So how many dollars are in each gallon? And so that's 2.7. And so our total cost, our total amount, is going to be the number of groups that we have, the 1.36, times the number of items per group, which is 2.7. Oops, 2.7. And so there we go. That's the answer or that's the arithmetic that we did earlier. We know that's 3.672. So there's our total cost. So again, the point here is that we wanted to know a total quantity, or in this case a total number of dollars, and we found it by multiplying decimals.